Today we're going to learn how to perform arithmetic operations and changing a polynomial to its standard form. Now to work on this lesson, you need to know how to combine like terms. You also need to know how to add and subtract integers or positive and negative numbers, and how to multiply and divide integers. Now by definition, polynomials are basically monomials with the combination of its sums and its differences. And examples of polynomials are x squared, y squared, and 4w squared, and 3x to the fourth minus 5x plus 1, and the number 13. Now, polynomials can be classified according to its degree and number of terms, and we have separate names or different names for these types of polynomials. Now, this is how you call your polynomials according to the highest exponent that the polynomial has and the number of terms that the polynomials have. Now, if you have a polynomial with a highest degree of 0, we call it constant. And if a polynomial has a highest degree of 1, we call it a linear polynomial. And a one-term polynomial is also called a monomial. Now, for a degree 2 polynomial, we call it quadratic. And a polynomial with 2 terms, we call them binomials. And for a degree 3 or a polynomial with the highest exponent of 3, we call it cubic polynomial. And if it has 3 terms, we call it a trinomial. Now, in general term, if you have a polynomial with exponent of 4 and above, we usually call it as a 4th degree polynomial or a degree 4 polynomial, or a 5th degree, 6th degree, or however or whatever highest exponent you have in your polynomial. We just call it in their general term. And the general term of polynomial with 4 or more terms, we can simply classify it or call it polynomial. Now here are some examples of the polynomials that we have right now, and we're going to classify them or name them according to its highest degree and the number of terms that polynomials have. Now for the first example, we have 7x plus 4, and you will notice that the highest exponent that we are seeing is 1 because of the variable x. And if you have a degree 1 polynomial, we call it a linear polynomial. And for this particular polynomial, we have 2 terms, so we will call this also a binomial. So collectively, we can call them linear binomial. And for example number 2, you'll notice that our highest exponent is 2 for 3x squared. So we'll call it a quadratic polynomial. And since it has it has 3 terms in its polynomial, we will call it a trinomial or a quadratic trinomial. And for the third example, we only have a single term polynomial with the highest exponent of 3, so it's a degree 3 polynomial or a cubic polynomial. And since it has a single term or one term, we will call it a monomial. So you will notice that the special terms or names that we have in a polynomial only goes for the highest exponent of 3, and we call it linear, quadratic, cubic, or monomial, binomial, and trinomial. Now for example number 4, we have 9x to the 4th plus 11x. So it's a degree 4 polynomial, and we will call it a 4th degree polynomial, or sometimes we call them also as degree 4 polynomial. Since its number of terms is only 2, we will call it a 4th degree binomial. And for the last example, we have 5, which means its highest exponent is 0, because any constant will have a variable raised to 0, and we know in the law of exponent that any number raised to 0 is equal to 1, and 5 times 1 is simply 5. So its degree is 0, and we will call it a constant. And since it only has a one term constant, we will call it a monomial. And sometimes we'll have special cases like polynomials written this way. We have 2x squared y to the 7th plus 3x to the 5th minus y to the 4th. So this is a 3-term polynomial or a trinomial, and you will notice that the first term has 2 variables, and whenever you have 2 variables, all you need to do is to add the exponents and see which one has the highest exponent. And in this case, 2 plus 7 is equal to 9. So in this type of polynomial, we can call it a 9-degree or degree 9 trinomial because its highest exponent is 9 from its first term. So this is how we classify polynomials according to its degree and the number of terms it has. Now, in standardizing a polynomial, you need to remember that any polynomials in standard form will have the highest exponent at the very beginning of its polynomial, and at the very end will be the lowest exponent or a constant. So when we classify or when we standardize polynomial, we need to simplify it by combining like terms. And when we say like terms, it means it has the same variable and same exponent. Now this is an example of a polynomial, and you will notice that we have 1, 2, 3, 4, 5, 6 terms in this particular polynomial. But if we simplify the polynomial by combining like terms, we'll be able to standardize this polynomial and name the polynomial to its highest number of terms and highest degree. And in this case, our like terms would be 2x squared and negative x squared. We also have 3x and x, and negative 4 and positive 9. So we have 3 sets of polynomial according to its degree and variable. So if we combine those polynomials, because they are like terms, we'll have x squared plus 4x plus 5, which we will call as quadratic trinomial. So this is how we standardized a polynomial by combining like terms. And sometimes the polynomials that we are given are in groups of 2 or groups of 3, like this one. And if we're going to be adding or combining like terms by addition, all we need to do is to combine like terms like what we did a while ago. And since we are just adding, all we need to do is to find polynomials with the same variable and same exponent. So 3x to the fourth and 7x to the fourth are the same, and negative 5x squared and negative x squared are called like terms, and we have 4x and 21x. So if we combine these sets of polynomial, we'll be able to produce a trinomial, which is going to be 10x to the fourth minus 6x squared plus 25x. So this is how we standardized polynomial by combining like terms. And in this particular case, this is a 4th degree trinomial or degree 4 trinomial. Now, if we can combine like terms by addition, we can also simplify or standardize polynomial by multiplication. Notice that in this example, we don't have a plus or minus in between the two groups. So if we're going to standardize or simplify this polynomial, we would need to multiply the polynomials by the distributive property. So by combining 2 plus 3x and 4 plus 5x by the distributive property, we'll multiply 2 to 4 plus 5x and 3x to 4 plus 5x, so we can simplify the polynomial or expand the polynomial. So we'll have 2 times 4 plus 5x and 3x times 4 plus 5x. So 2 times 4 plus 5x is 8 plus 10x, and 3x to 4 plus 5x will give us 12x plus 15x squared. So this will be our second level of the polynomial by the distributive property, and by applying the associative property, we know we can just get rid of the parentheses and combine like terms. So in this case, we'll notice that 10x and 12x are the only terms that are considered like terms. So we can combine them and we'll end up with 8 plus 22x plus 15x squared. Now this is not yet in standard form because the first term should always be, or the leading term should always be the highest exponent, and the last term should always be your constant or your lowest exponent. So the standard form of your polynomial would be 15x squared plus 22x plus 8 by rearranging the form of your trinomial. So in this case, we will call this quadratic trinomial. So this is how we standardize polynomial by addition and multiplication. Now we'll see a different set of polynomial which uses division to simplify or standardize the polynomial. And in this case, we have 2x cubed plus 6x squared plus 4x divided by 2x. Now we have two ways on how to divide polynomials. One is when your denominator is a monomial, and the other one is when your denominator is a trinomial or a binomial, or a polynomial with two or more terms. Now, if you're going to divide a polynomial with a monomial, dividing it would be simple, because what you can do is you can separate your fraction or your polynomial into three sets of fractions. So you can separate 2x cubed and 2x, 6x squared and 2x, and 4x and 2x. And you will notice that you can now simplify each term by simplifying regular rational expression. So 2x cubed and 2x can be simplified because they're both can be divided by 2, and your x squared divided by x will turn into x squared. So you'll have x squared for your first term as its simplest form. Now for the second term, we can simplify 6 over 2 and turn it into a 3, and x squared divided by x is simply x. So we'll end up with 3x in our second term. And the simplest form of our last term is simply 2, because we can simplify 4x and 2x by dividing it. So our polynomial is now x squared plus 3x plus 2, which is a quadratic trinomial. So this particular method only works when your denominator or divisor is a monomial. Now on our next example, we'll see a different polynomial, because now our denominator or divisor is now a binomial. And when you have a binomial as a divisor, we will be using long division to divide our polynomial. And in dividing polynomial, you simply divide the first term by your divisor, which is x, and x squared divided by x will give us x, and that will be our first quotient. And we will align it to our middle term or to the term with an exponent of 1. So we'll have to write x in our first part of our quotient. And just like long division, after you found your first term, you will multiply it back to your divisor, and x times x minus 2 is simply equal to x squared minus 2x. And just like long division, we're going to subtract our x squared plus 2x with our our new polynomial by changing the sign of our bottom term or bottom polynomials. So x squared minus 2x by subtraction will turn into negative x squared plus 2x. And by combining like terms, we can cancel out x squared and x squared because they are zero pair. And 2x plus 2x will turn into 4x. And then we can now bring down negative 8 in our second stage of our long division. And now we're just going to repeat the steps that we did and divide 4x by x. And 4x divided by x is simply 4, and we'll have x plus 4 in our quotient. And just like long division, we will multiply 4 to x minus 2, so we'll end up with 4x minus 8. And by subtracting it, we will change the sign of our bottom polynomial, and it will turn into negative 4x plus 8. And by combining like terms, you will notice that both the first term and the second term are zero pairs, so we'll end up with 0 as our last level. And when we have 0 in our long division, to our last stage of our long division, we know that we don't have a remainder for our divisor, which means x minus 2 is a factor or one of the factors of x squared plus 2x minus 8. Now, just like multiplication, we know that if we multiply the quotient and the divisor, it will equal to your x squared plus 2x minus 8, or your dividend. So x plus 4 multiplied by x minus 2 using the FOIL method or distributive property will end up with x squared minus 2x plus 4x minus 8. And by combining like terms, we'll have an answer of x squared plus 2x minus 8, which is the same as the numerator of our polynomial. So this is how we divide polynomial using long division. Now, another way of performing division in polynomial, we call it synthetic division. And what we're going to do is I'm going to use the same polynomial and use a different method on how we're going to divide x squared plus 2x minus 8 by x minus 2. So by synthetic division, the step would be pretty simple because we're just going to be using the coefficients and the zeros of our denominator in our division. So your first move is to convert your divisor by equating it to 0. So we would just use the solution of our divisor. So x minus 2 is equal to 0 will give us 2. So in synthetic division, you will be using the zeros of your divisor. So you will always equate your divisor to 0 and solve for x. So you will have your new divisor for your synthetic division. And after you have converted your divisor, you're going to use your coefficients from your numerator and use it in our synthetic division. So x squared plus 2x minus 8 will have 1, 2, and negative 8 as the coefficients of our polynomial. And now that we have set up our synthetic division, we can now perform our synthetic division using these steps. So the first step in performing synthetic division is to bring down your first term, which is 1, and multiply it to your divisor, which is 2. So 1 times 2 is equal to 2, and now you will combine it or add it to your second term. And 2 plus 2 is equal to 4, which gives you your second term. So this will be your steps in performing synthetic division. So we're just going to repeat this by multiplying 4 times 2, which is equal to 8, and combine negative 8 and 8, which gives us 0. So as you will notice, we'll have 140 as our quotient in synthetic division, which is not yet looking like a polynomial. So to change it into a polynomial, the rule is the highest exponent of your polynomial or your numerator, you subtract 1 from it, and that will be the highest exponent of your quotient. So the highest exponent of our dividend or our numerator is x squared. So that means in our quotient, its highest exponent will start at 1. So we'll have 1x to the 1, 4x to the 0, and the last term in our synthetic division will always be your remainder. So by writing this out and simplifying this, we'll end up with x plus 4 because x raised to 0 is equal to 1, so we can cancel x to the 0 in our equation or polynomial, leaving us with x plus 4. And x plus 4 is our quotient from this polynomial because just like what we did a while ago using long division, our quotient is also x plus 4. So synthetic division is another way of using or dividing polynomial using the coefficients of your fraction. Now, to give you another example of synthetic division, we'll have x cubed minus 3x squared plus x minus 2. Just like what we did on our other example, we will convert the denominator and equate it to 0 so we can have our new set of divisor. So x plus 3 is equal to 0, minus 3 on both sides, so x is by itself, will be negative 3. So our divisor will be the 0 of your denominator, which is negative 3, and using the coefficients of your numerator, we'll have our synthetic division set up for our division. So we'll have 1, negative 3, 1, and negative 2 as the coefficients of our synthetic division. So just like what we did on the previous example, we'll bring down 1 and multiply it to our divisor. So 1 times negative 3 is equal to negative 3. And we will use negative 3 to combine to our second term. And negative 3 minus 3 or negative 3 plus negative 3 is negative 6. And this will be our second term for our quotient. And we repeat the same steps. So negative 6 times negative 3 is 18. We add them up. So 1 plus 18 is 19. We multiply 19 to negative 3, and it gives us negative 57. And combining those two, negative 2 minus 57 is negative 59. So just like what we did a while ago, if the highest exponent of your polynomial is 3, your quotient will be or will have a highest exponent of 2. So you always just subtract 1 from your highest exponent from your original polynomial for your quotient to be valid. So you'll end up with 1x squared negative 6x to the first power, 19x to the 0 power, and negative 59 is going to be our remainder. So rewriting our polynomial to its standard form, we'll end up with x squared minus 6x plus 19 minus its remainder, which we can write in fraction form as 59 all over x plus 3. And this is how we classify and standardize polynomial by combining like terms, multiplying, and dividing.